Hello everybody. In this session we are going to see about logistic regression, and this is the presentation outline I have in store for you. We will just understand what are the applications of logistic regressions, meaning why we need to study logistic regression, and logistic regression in business world, how it is really used, and then we dwell deep on binary logistic regression. Binary logistic regression, as you might be knowing, when you have a dependent variable which has only two categories, right? Say for example, where they have a disease, yes or no, whether the customer churn or not, yes or no, binary decisions if you want to make, that's binary logistic regression for us. And then we will take an healthcare data example and then run a logistic regression and try to understand the results, and we do the interpretations, and then at the end of it we will understand how to validate the model so that before deploying it, so all the things are in place. Moving on, what are the applications of logistic regressions? These are some of the things that you might have come across, right? Say for example, there is a financial transaction going on, and then I want to understand whether it is a genuine transaction or a fraudulent transaction, right? So yes or no. Yes means it's a fraudulent transaction and no means it's a non-fraudulent transaction. Similarly, customer wants to know, particularly telecom sector, people want to know when the customer will churn, that is when the customer will stop using their service and move on to other service, that is whether customer churn, yes or no. And if I want to understand as a network manager whether the email coming in is a spam email or not, right? So that can be analyzed using logistic regression, that is spam or not spam. If you look at it, all these things have two classes, which is we call it as a binary class. In this case of a fraudulent transaction, I want to find yes it is a fraudulent transaction or no it is a fraudulent transaction. In terms of customer churn, yes the customer will churn, that is move out of my company, and no the customer will not churn. Email, yes it is a spam, and no it is not a spam, right? So these are all binary classes, and not necessarily we use logistic regression only for two class. You can use logistic regression for more than two class. In this case, say for example, a credit classification example, a bank want to classify its customers based upon the credit worthiness, so it can come up with some variables, and based upon which they can classify the customer into low credit worthiness, medium credit worthiness, and high risk credit worthiness, right? So in terms of credit classification, so in this case if you see, this is a 3-class classification, and the above all the things are 2-class classification. So this is 2-class and hence it is called binary class, and this 3-class and hence it is called multi-class, and the binary class where dependent variable have only 2-class, we call it as binomial logistic regression. When you have more than 2 classes, we call it as multinomial logistic regression, right? Multinomial logistic regression. So this is pretty much a simple understanding of what is the application of logistic regression, and what is a binary logistic regression, which is binomial logistic regression, and what is a multinomial logistic regression. Let's move on. So we are going to concentrate only on binary logistic regression, and then we try to understand how it can be applied. So mostly in many of these situations we only go for binary logistic regression in even in the real world. Let's take an example and try to understand and appreciate what is binary logistic regression. Let us say I have a dependent variable called disease, and then I want to understand whether a probability of this is, right, this disease, let us say a brain tumor, right, just to take an example, a brain tumor, right, as a disease, whether the age factor of a person is related to brain tumor or not, right? So I am getting the data from the patients, and I am classifying people who have disease as 1, yes they have a brain tumor, and no as 0. Now the question arises, what is the difference between multiple linear regression and logistic regression? As you might have correctly understood now, multiple logistic regression, right, first criteria is a dependent variable has to be metric, and in logistic regression, as you can clearly see, the dependent variable is non-metric, that is categorical. So this is a clear cut difference between multiple linear regression and logistic regression. Now, if you remember, in multiple linear regression we make use of something called as best fit line. So, getting the best fit line using something called ordinary least square method, right. So, now can we apply the ordinary least square method to the logic to the binary logistic regression also, right. So, let us clarify that before we go into further, right. So, let us take an example, right, of disease. Coming back to the example of disease and age, let us say this is how it is classified, right. So, this is based upon the past data. Now, what happens if I try to fit a best fit line? So, something like this I will fit in, right. So, now this is the best fit line, and then if I take a cutoff of this, right. So, here, and then whatever towards the left of the line becomes no, whatever comes become the right of the line, right. So, where the cutoff line I classify as yes. So far it works perfectly fine, only one misclassification is here, right. But what happens if too many data are there? Let us say if the data is coming here, then the best fit line might change to this. Now, the same cutoff if you use here, right, let us say this is a 0.5 cutoff, right. 0.5 and above we classify as 1, 0.5 and below we classify it as 0. So, now if the same cutoff I use, right, here, now look at this, number of misclassification increases, right. So, two things that we need to make into picture here. So, we cannot apply ordinary least square to binary logistic regression because there will be lot of misclassification, plus the dependent variable in binary logistic regression is not a continuous variable, it is a categorical variable, and hence it demands some other function or some other logic in which we can relate the dependent variable and independent variable. Obviously, we cannot use ordinary least square method like we have used for MLR. So, this is the first and foremost understanding we need to have before we try to establish relationship between the dependent variable and independent variable in logistic regression, where dependent variable is categorical. Now, the question arises, what is the way out? Now, let us go for what statisticians have thought about it and has given to us in terms of solving this problem where your y, the dependent variable, is categorical. So, the same question I am asking to you, if ordinary least square cannot be applied, what is the way out? Which function we can use to establish a relationship between categorical dependent variable and the numerical or non-numerical independent variables? Think about it.